Coca Cola production in 2026 is one of the most advanced beverage manufacturing processes ever built. Modern factories operate like giant automated systems where robotics, precision engineering, artificial intelligence, and industrial chemistry work together, continuously to produce millions of bottles every day. Everything inside the factory is designed around one objective. Every Coca Cola must taste exactly the same. Whether it is produced in the United States, Japan, Germany, Brazil, or anywhere else in the world, the flavor, sweetness, carbonation, and texture must remain consistent. Achieving that level of precision requires an incredibly controlled production process where every ingredient, temperature, pressure level, and machine movement is monitored constantly. The entire process starts with water. Water is the main ingredient in Coca Cola, making up almost 90% of the final drink. Because of that, the purification process is extremely important. Before water enters production, it passes through several cleaning stages designed to remove impurities and create a perfectly controlled base. The first stage is mechanical filtration. Incoming water moves through large industrial filters that remove dirt, rust, sand, and microscopic particles. After that, the water enters activated carbon filtration systems. These systems absorb chlorine, unwanted odors, and chemical compounds that could affect flavor. Next comes reverse osmosis. In this process, the water is pushed through ultra-fine membranes under high pressure. These membranes block minerals, bacteria, and microscopic contaminants at a molecular level. The result is highly purified water with tightly controlled chemical properties. After reverse osmosis, the water enters ultraviolet sterilization systems. Powerful UV light destroys microorganisms without adding chemicals into the water supply. At this stage, the water is cleaner and more controlled than normal bottled drinking water. But purification alone is not enough. The mineral balance also has to be adjusted precisely because water chemistry affects taste. Coca-Cola factories use automated sensor systems that continuously monitor pH levels, mineral concentration, conductivity, and temperature. If anything moves outside acceptable ranges, the system can stop production automatically. Consistency is critical. Even small changes in water chemistry could slightly alter the flavor of the final drink. Once purified and balanced, the water is stored inside large stainless steel tanks where temperature conditions remain tightly controlled. Now the next stage begins: syrup preparation. The Coca-Cola syrup concentrate is one of the most protected trade secrets in the world. While exact details remain confidential, the concentrate contains flavor compounds, acids, caramel coloring, caffeine, and sweeteners. Factories operated by the Coca-Cola Company and its bottling partners receive carefully controlled concentrate shipments from specialized production centers. Modern facilities in 2026 often produce multiple Coca-Cola products simultaneously: classic Coca-Cola, Coca-Cola Zero Sugar, Cherry Coke, Vanilla Coke, limited edition flavors, regional variations. Instead of workers manually mixing ingredients, industrial software controls the entire preparation process automatically. Digital recipes stored inside factory control systems tell the machinery exactly how much concentrate and sweetener to use for each product. Automated dosing systems pump ingredients into massive stainless steel blending tanks using electronically controlled valves. The accuracy is extremely high. Modern production systems can measure ingredients down to fractions of a gram while processing thousands of liters every minute. Inside the blending tanks, industrial mixers continuously circulate the syrup to maintain complete uniformity. The syrup itself is extremely concentrated. At this point, it tastes overpoweringly sweet and far too strong for consumption. It is specifically designed for industrial dilution later in the process. Once the syrup is ready, it moves into high-speed inline blending systems. This is where the purified water and syrup finally combine. The blending process is controlled by precision flow meters that constantly measure how much water and syrup are moving through the system. Every ratio must remain exact. If even slight variations occur, the drink could taste different. The entire process happens continuously at extremely high speed. Thousands of liters flow through the mixing systems every minute, while industrial computers monitor pressure, temperature, and liquid flow in real time. Temperature control becomes especially important during this stage because the beverage must be cooled before carbonation. Cold liquids absorb carbon dioxide more efficiently than warm liquids, and carbonation is one of the defining characteristics of Coca Cola. Once the liquid reaches the correct temperature, it enters sealed carbonation chambers. Inside these chambers, carbon dioxide gas is injected into the beverage under high pressure. The pressure forces the gas to dissolve into the liquid. This creates a signature fizz and sharp sensation associated with Coca Cola. Modern carbonation systems in 2026 are heavily automated. AI-assisted monitoring software constantly measures carbonation levels and pressure conditions. Sensors analyze dissolved gas concentration in real time and automatically adjust pressure if needed. Too much carbonation creates excessive foaming. Too little carbonation makes the drink taste flat. The entire process is engineered to maintain perfect consistency across millions of bottles. Once carbonation is complete, the finished Coca Cola is ready for packaging. But the packaging itself involves another highly advanced manufacturing process. Most Coca Cola products today are packaged in aluminum cans, glass bottles, or PET plastic bottles. Many factories now manufacture their own plastic bottles on-site to reduce transportation costs and improve efficiency. The bottle manufacturing process starts with small plastic preforms. These preforms resemble thick, transparent test tubes. Robotic feeding systems load the preforms into blow molding machines where they are heated until soft and flexible. Then high-pressure compressed air rapidly expands them inside bottle-shaped molds. Within seconds, the plastic stretches into the familiar Coca-Cola bottle shape. Modern blow molding machines can produce tens of thousands of bottles every hour. As bottles leave the molding systems, they immediately pass through automated inspection stations. AI-powered cameras scan every bottle for cracks, thin spots, structural weaknesses, or shape defects. Any bottle that fails inspection is automatically removed from production before reaching the filling line. Approved bottles then move into cleaning systems. Some facilities rinse bottles using purified water, while others use sterile air systems depending on the packaging process. From there, empty bottles travel toward the filling section. This is one of the fastest and most carefully controlled parts of the factory. Rows of empty bottles move into enormous rotary filling machines, spinning continuously at high speed. Inside the filling area, contamination prevention becomes extremely important. Modern Coca Cola factories use filtered air systems and controlled production environments to reduce airborne particles and bacteria. Precision filling valves dispense exact quantities of Coca Cola into every bottle. The timing has to be perfect. Overfilled bottles waste product. Underfilled bottles create quality issues and customer complaints. In 2026, filling systems use machine learning software connected to thousands of sensors throughout the line. The system continuously monitors liquid flow, bottle positioning, pressure conditions, and fill height. If even slight inconsistencies appear, the software automatically adjusts filling speed and valve timing instantly. Some production lines can fill more than 100,000 bottles every hour. As soon as bottles are filled, they move directly into sealing systems. Caps are applied and tightened using torque-controlled machinery calibrated to exact specifications. If caps are too loose, carbonation slowly escapes. If caps are too tight, the bottles become difficult to open. Every sealed bottle then enters one of the most advanced quality control stages inside the factory. Artificial intelligence now performs most inspection work in Coca Cola production facilities. High-resolution cameras photograph every bottle from multiple angles, while machine learning software analyzes the images instantly. The AI checks for incorrect fill levels, leaking caps, crooked labels, bottle damage, packaging defects, foreign particles, seal failures, barcode problems. Even microscopic defects invisible to human workers can trigger automatic rejection. Human inspectors simply cannot match the speed of modern production lines. AI systems can scan thousands of bottles every minute without stopping. And unlike human workers, they never lose concentration or become fatigued. The inspection systems also improve continuously. Machine learning software studies production data to identify patterns associated with recurring defects. Engineers can then adjust equipment before larger problems develop. After inspection, approved bottles move into labeling systems. Labels are applied automatically at extremely high speed using precision alignment systems. At the same time, laser printers add expiration dates, production codes, and traceability information directly onto the packaging. Every product receives a unique tracking code. This allows Coca Cola to trace any bottle back to the exact factory, production line, and production time if a problem occurs later. Next comes secondary packaging. Robotic systems group bottles into packs using shrink wrap, cardboard carriers, or reusable transport crates. Automation dominates this section of the plant. Large robotic palletizers stack finished cases onto pallets with incredible speed and precision. The robots carefully arrange cases to maximize stability during transportation. Once palletized, products move into warehouse operations. Warehouse systems in 2026 are highly automated. Many Coca Cola facilities now use autonomous forklifts equipped with navigation sensors and digital mapping systems. These robotic vehicles transport pallets through warehouses without human drivers. Warehouse management software tracks every pallet in real time and directs products automatically toward shipping zones. The final stage is distribution. Finished Coca Cola products are loaded onto trucks, rail systems, and shipping containers for delivery across stores, restaurants, vending machines, and distribution centers around the world. AI-powered logistics software helps manage this process by predicting demand using weather forecasts, seasonal trends, local events, and sales data. If temperatures rise in a certain region, the system may automatically increase shipments because soft drink demands usually increases during hot weather. The speed of the overall production process is remarkable. Inside a modern Coca Cola facility, water purification, syrup preparation, blending, carbonation, bottle manufacturing, filling, inspection, packaging, and palletizing happen continuously with almost no interruptions. A bottle can move from mixing tank to shipping pallet in only minutes. But despite the speed and automation, consistency remains the most important priority. Every ingredient ratio, pressure level, temperature setting, and machine movement is controlled carefully to ensure the final product always delivers the same experience. That consistency is what transformed Coca Cola from a small soda fountain drink into one of the largest beverage brands in history.